Welcome to Lesson 7 on colligative properties. Our lesson objectives determine the effect of adding solute to a solvent on its boiling and freezing point, compare the boiling and freezing point of a solution to that of pure water, and determine the effect of concentration of solute particles on boiling and freezing point. And so we're going to look at something called colligative properties in this lesson. These are properties that depend upon the concentration of our solute particles and actually not their identity. And so we'll look at two colligative properties. The first one's going to be something called boiling point elevation. When we look at the word elevate, that means to increase. And so a common misconception is that when you add, for example, salt to water when we're going to boil pasta, that it actually makes the water boil faster. And in reality, it's the opposite. So when we add a solute to water, it's actually going to elevate or increase the boiling point. And so adding salt to water would increase our boiling point to, let's say, 102 to 103 degrees Celsius, which would take slightly longer to reach boiling. Now, to be honest, you'd have to add a pretty large amount of salt to get this increase, but it does increase. And why does it increase? Well, let's look at this very oversimplistic diagram here. And so we have our water salt mixture, and you can see these particles now, these solute particles, are interfering with water's ability to quote-unquote escape into the gas phase. What it's really doing is it's lowering our vapor pressure because we have less water molecules in the gas phase, and a lower vapor pressure means that we'd have to have a higher temperature to get this substance to boil. So the boiling point will elevate a few degrees Celsius. So let's check your understanding. Can you determine the effect of adding solute to a solvent on its boiling point? The next colligative property we're going to look at is something called freezing point depression. And the word depress means to decrease. So when we add a solute to water, it's actually going to decrease the freezing point. And so an example we talked about in class in our lab is putting salt on roads causes the ice to melt. And it does that because it lowers the freezing point. It depresses the freezing point below 0 degrees Celsius. And since it's not 0 degrees Celsius out, it is going to melt. And so let's look at what's going on the molecular level. So in pure water, we have this crystallization here. The water is solidified in the solid form because we have all these intermolecular forces, this hydrogen bonding occurring. And when we add a solute to our water, the solute interferes with water's ability to form these intermolecular forces of attraction, and it destabilizes it. It makes it harder for it to crystallize, and so the temperature has to be decreased even more in order for it to freeze, so that freezing point drops. So let's check your understanding. Can you determine the effect of adding solute to a solvent on its freezing point? And now can you compare the boiling and freezing point of a solution to that of pure water? So now that we know the effect on the boiling point and freezing point when we add a solute, let's look at different types of solutes and see their effect. And so the first one here is a covalent substance. And when we add a covalent or a non-electrolyte solute, it is not going to dissociate into ions. This does not break apart at all when we put it into water. And so we're going to be left with one particle. When we look at sodium chloride, this is ionic or an electrolyte. This is going to dissociate into ions. The NaCl is going to break apart into the sodium ion and the chloride ion. So we have two ions, so therefore two particles. And in this example, for this ionic or electrolyte, we have Na2CO3. This is going to break apart into two sodium ions and one carbonate for a total of three particles. And so we see as we add, as we get more particles, we have a greater effect on our freezing point and our boiling point. So boiling point elevation is going to go up and freezing point is going to go down as we increase the number of particles that we get. And so ionic substances are much better at affecting the freezing point and boiling point than covalent substances. And again, the more particles we have, the more interference that we get with water escaping to the gas phase in boiling point or solidifying in our freezing point. So let's see two examples. So what occurs when sodium chloride is added to water? So now if we're adding a ionic substance to water, we know it's going to break apart into two ions. This is going to affect our boiling point and our freezing point. What does it do? Well, boiling point elevation is going to elevate the boiling point, so that's going to increase. So it's either choice 1 or 2. And then it's going to depress the freezing point. Freezing point is going to go down, and so that's going to be choice 1. The boiling point of the solution increases and the freezing point decreases. So now let's look at if we have the same substance. So we're using sodium chloride, but now one of them is a higher concentration. So we have a 2 molar aqueous solution of sodium chloride and a 3 molar aqueous solution of sodium chloride. So remember, this is molarity, and it's a concentration measurement. And so if we have a higher molarity, that means we have more solute. If we have more solute, we have more particles. If we have more particles, we're going to have a greater effect on the melting and, on the freezing and boiling point. And so the 3 molar aqueous solution is going to have a greater effect on that. And so the boiling point of the 3 molar solution is going to be higher and the freezing point is going to be lower. So a higher boiling point and a lower freezing point, choice 4. So recapping what we just learned, we know that the more particles we have the greater effect on increasing the boiling point and decreasing the freezing point. And so ionic substances do that better because we have more particles as they break apart into ions. And if we're looking at 2 of the same type of solutes, like in this case here, both are sodium chloride, well, the higher concentration is going to give us more particles and have the same result. So what are some applications to colligative properties? Well, we know about salting our icy roads. That decreases the freezing point. Same thing for making ice cream. And something which is called antifreeze in our vehicles. We'll put it in our radiator in our cars. That is also going to decrease the freezing point. So if you look here in this antifreeze on the label, if you have a 50% antifreeze and 50% water in your radiator, it's going to decrease your freezing point to -34 Fahrenheit and increase your boiling point from 212 Fahrenheit to 265. So we have our boiling point elevation and freezing point depression. So this car is going to start with no problems in the winter under most cold temperatures, and even in extreme heat, it will be protected as well. And if you increase now, you see here, to 70% antifreeze and 30% water, so now we've increased our concentration, our molarity, then we have a greater effect. We see a bigger drop in our freezing point and a bigger increase in our boiling point. So let's check your understanding. Can you determine the effective concentration of solute particles on boiling and freezing point? At this point, you should be able to determine the effect of adding solute to a solvent on its boiling and freezing point, compare the boiling and freezing point of a solution to that of pure water, and determine the effective concentration of solute particles on boiling and freezing point.